Good afternoon and welcome to our presentation on our mission to be new, S.C.U.F.F.E.D, presented by Rocket Mortgage. S.C.U.F.F.E. stands for the Satellite Constellation for uncovering foreign facets in visionary design. The team members involved are Ryan Bennett, Walker Tiffany, and Sam Stewart. Our orbit design. To ensure that our orbit was designed as well as possible, we first found the JSV value for the given satellite constellation, with just one satellite with a circular orbit with a radius of 1 kilometer. This JSV value was around 90,000, which was confirmed by the lab TAs. The final constellation had 4 satellites in it, all of which had a radius of periapse of around 540 kilometers with an eccentricity of 0. The final JSV for this constellation was 12.246 million.
Our main goals in creating this constellation was to vary two anomalies such that each spacecraft should see a different section of Bennu at a given time. Additionally, we wanted to prioritize high inclination and polar orbits as orbits that have the least effect from PSR. Additionally, we found that if we set the orbit for each spacecraft to have a RAND value of 9 degrees, we could further decrease the effect of solar radiation. To determine the number of spacecraft, if we were to prioritize polar orbits, a well-distributed constellation based on true anomaly would need 2 satellites in polar orbit and 2 other in high inclination. To quickly go through many different constellation design, we made a tool to create a constellation based on 3 main parameters. Given the radius of periapse, eccentricity, and number of satellites, it would automatically create initial conditions to create our constellation. Not all of our constellations were as successful throughout the process. In the upper left, you can see one constellation of 4 satellites that crashed very soon after the start of the simulation and did not create any usable science. In the lower right, we see another constellation with only 2 satellites. Although it did complete its required mission design of 1 week, it would crash soon after with heavy orbital deterioration and a JSV value of only 2.1 million.
Now, onto how we know that our orbit design is the best. As mentioned before, our orbits are highly optimized with an unprecedented JSV value of over 12.2 million. This comes out to over 3 million per satellite. Additionally, our variation between each orbit means that we will be viewing unique facets instead of repetitive viewings of the same facet. Finally, extensive testing prior to our final design means that our constellation is as optimized as possible. Now, while I let this animation play, there are a few other design details that I'd like to address. As mentioned previously, SRP perturbations will cause our orbits to increase in eccentricity with time. This will mean that collisions with Bennu are going to happen. However, with our final orbit design, these collisions won't happen until roughly 2 weeks after we begin our orbits. Simple burn maneuvers and delta V's can prevent this and can even allow for the recovery of our satellites.